Okay, in this short video I'm going to look at the solutions to the questions that were given for homework for the week ending the 23rd of November. And it was a series of algebra questions that were basically just taken from Leaving Cert exam papers. Okay, so let's have a look. If f of x is equal to x squared minus 7x plus 12, we've been asked to show that f of x divided by f of x plus 1 simplifies to x minus 4 over x minus 2. Okay, so first of all we're going to calculate what f of x plus 1 is. Now f of x plus 1 just simply means put in x plus 1 instead of x. So instead of x squared, it's going to be x plus 1 squared. Instead of minus 7x, it's going to be minus 7 times x plus 1, and then plus 12. So f of x plus 1 is equal to square the first, x squared, multiply the first by the second and double your answer, plus 2x, square the last, you get plus 1, and then multiply this out, you get minus 7x, and minus 7 by 1 is minus 7, and then plus 12. So when I simplify that down, I get f of x plus 1 equals x squared minus 5x, that's 2x minus 7x, and then we have 1 and 12, which is 13, and 13 minus 7, which is plus 6. Okay, so literally what I've done now is I found out that f of x is equal to x squared minus 7x plus 12, and I was actually given that in the question, and I can put that in here on the top half of the fraction. Now I've just worked out that f of x plus 1 is x squared minus 5x plus 6, so now I'm going to put that in here on the bottom part of the fraction, and then I'm just hoping that my answer is going to simplify down to x minus 4 divided by x minus 2. So here goes. F of x divided by f of x plus 1 is equal to, f of x divided by x plus 1 is x squared minus 7x plus 12 divided by x squared minus 5x plus 6. And now what I'm going to do is I'm going to factorize the top and the bottom. Now if I factorize x squared minus 7x plus 12, I clearly get x minus 3 multiplied by x minus 4, and if I factorize the bottom line, I get x minus 3 multiplied by x minus 2. Now you can very clearly see that x minus 3 on top and x minus 3 on the bottom cancel out, so put it all together and we get that f of x is equal to x minus 4 divided by x minus 2, which is exactly what we were required to do. Okay? So now we're going to move on to part 2. So that's part 1 here, completely covered. Now in part 2 of the question, we're asked what is the range of values of x for which f of x over f of x plus 1 is greater than or equal to 3. So now let's have a look at that. So f of x divided by f of x plus 1 greater than or equal to 3 means that x minus 4 divided by x minus 2 is greater than or equal to 3. Okay, just basically putting this part here, sorry, that should be f of x divided by f of x plus 1, my apologies. So this part here, x minus 4 over x minus 2, needs to be greater than or equal to 3. Okay? Now, I know that whenever we have an inequality, we need to be sure that we're multiplying by positive numbers to ensure that we don't affect the inequality in any way. So what I'm going to do now is I'm going to multiply both sides of this inequality by the square of the bottom line. So x minus 2 squared. Okay? Now what that does is it gives me x minus 4 multiplied by x minus 2 to be squared divided by x minus 2 is greater than or equal to 3 times x minus 2 squared. Now on the left hand side of the inequality we have an x minus 2 on the bottom and we have two x minus 2's on top, so one of them cancels. So I'm left with x minus 4 multiplied by x minus 2 is greater than or equal to 3 times x squared minus 4x plus 4. If I square out the brackets, square out x minus 2 and you get x squared minus 4x plus 4. Now on the next line I'm just going to completely multiply out the top and the bottom. If I multiply out the top I get x squared minus 6x plus 8 is greater than or equal to 3x squared minus 12x plus 12. And that means that 0 is greater than or equal to 2x squared minus 6x plus 4. Okay? Just bringing everything over to the right hand side. That becomes minus x squared, that becomes plus 6x, and that becomes minus 8. Now I'm going to divide across by 2 and swap sides. So I get x squared minus 3x plus 2 is less than or equal to 0. When I swap the sides of the inequality, I have to reverse the direction of the inequality. So these are the typical questions that we've done in class very, very many times. And obviously there's a couple of key things that we need to do. So everything that I'm doing over here on the right hand side is absolutely critical. So first of all what I do is I let f of x, well we've used f of x already so we'll call it g of x. Let g of x equal x squared minus 3x plus 2. Now two things. First of all, I know it's a U-shaped curve since the coefficient of x squared is positive. Okay, so the number in front of x squared is a plus number, so that means it's a U-shaped curve. Now secondly, I need to know where it crosses the x-axis, and to do that I simply let g of x equal 0. So let the function x squared minus 3x plus 2 equals 0. If I factorize that, I get x minus 2 multiplied by x minus 1 equals 0, which means that my two possible answers are x equals 2 or x equals 1. Okay? Now if I was to draw this curve, if we were to very quickly draw a diagram of that curve, we would end up with something like this. Our x-axis is obviously horizontal, like that line that I just drawn there. And then it's a U-shaped curve, so it comes down like this, and it crosses the x-axis in two different places. Crosses the x-axis at plus 1 and also at plus 2. So here's the function that I've called g of x. Okay? So this function over here is graphed over here. Okay? Now the next thing that I do is I look back at the inequality here, the bit in blue. Now that function less than or equal to 0 is the equivalent of g of x is less than or equal to 0. Now effectively that means where is the curve under the x-axis? Okay, and I think we can all see very clearly that it's beneath the x-axis from 1 up to 2. Okay, now I'm going to make a tiny error here, and I want you to think about what the mistake is. According to this, my answer should be 1 is less than or equal to x is less than or equal to 2, x an element of R. Now you might think that that's the answer because we had less than or equal to up here, and yes, I've got less than or equal to down here, so it appears to be 100% correct. But if you think back a little bit, we've effectively solved x minus 4 divided by x minus 2 is greater than or equal to 3. Now the problem with this is, if I put in 2 instead of x on the bottom line, I get 2 minus 2, which is 0. Now obviously we know we can't divide by 0, so you need to be extremely careful that less than or equal to sign needs to be a strictly less than sign, like that. So actually that's the correct answer, so just be very careful at the very end before you commit to the answer that you double check that it's not breaking any of the rules in the original question. Okay, so again, just a quick run through the question. All I did at the beginning was I found out what f of x plus 1 was, and I subbed in, instead of f of x and f of x plus 1, f of x on top and f of x plus 1 on the bottom here, factorized and solved. So when we got to here, we were left with just x minus 4 over x minus 2. Then all we did was we solved f of x over f of x plus 1 is greater than or equal to 3. So we put this in instead of f of x over f of x plus 1. And from then on, we just multiplied by the square of the bottom line and simplified as much as we possibly could. Now, as we know from class, this is a bread and butter standard leaving cert question. And all of this stuff over here on the right hand side is of critical importance, so you need to make absolutely sure in the exam that you actually write it down. Okay? Now, on to question 2. Now, what we're told here is that this function has roots at plus p and minus p. Okay, now we know that that means if the roots are x equals p and x equals minus p, the factors then must be x minus p and x plus p. So this means that if we have two individual factors, the product of the two factors must also be a factor. So x minus p multiplied by x plus p, which is the difference of two squares, it's x squared minus p squared, that is a factor also. Okay, so we now know this much, that x squared minus p squared is most definitely a factor of our original function. Now, if x squared minus p squared is a factor, it means that it divides in evenly. So what I'm going to do now is I'm going to divide x squared minus p squared into my function, and I'm hoping that when I let the remainder equal to 0, that I'm going to be left with BC equals AD. Okay, so let's give it a go. We have x squared minus p squared, and we're dividing that into ax cubed plus bx squared plus cx plus d. Now first off, ax cubed, first part here, divided by the first part here, ax cubed divided by x squared is ax. Ax multiplied by x squared is ax cubed, and ax multiplied by minus p squared is minus a p squared x. Now note where I wrote that. I wrote x's underneath x's and x cubes underneath x cubes, so that's very important. Now to cancel the x cubes, I need to change the signs on the bottom line, so that plus will become minus, which means that that minus will become plus. Now automatically that means that my x cubes disappear, and I'm left with bx squared, and then I'm left with c plus ap squared multiplied by x, and then obviously we have plus d. Okay? Now next up then we need to repeat the process, so I need to divide this part here by this part here. Now bx squared divided by x squared is just b, so that's plus b. We have b multiplied by x squared, which is bx squared, and then we have b multiplied by minus p squared, which is minus bp squared. And obviously I've written it over there because it doesn't have an x in it, so constants underneath constants. Now usual thing, we try to cancel again, so I change that sign to cancel the bx squareds, but then I've also got to change that sign to a plus. So this minus over here on the this plus over here on the left turns to a minus, and the minus over here turns to a plus. Now when we cancel then, we have bx squared minus bx squared, which cancels. We have c plus ap squared multiplied by x, and then we have plus d plus bp squared. Okay? Now it is obviously impossible to divide x by x squared evenly. Okay? So that means that obviously there's no point in doing any more long division. Now we were told it was a factor, so since we were told it is a factor, this implies the remainder is equal to 0, which means that c plus ap squared equals 0 and d plus bp squared equals 0. Now remember, we're trying to prove that BC is equal to AD up here. Okay? So from this one, I can see that C is equal to AP squared. Sorry, C is equal to minus AP squared. So AP squared is equal to minus C, if we go that way about it, which means that P squared equals minus C over A. Now if we look over here on the right hand side, we can see that BP squared equals minus D, which means that P squared, if we divide across, is equal to minus D divided by B. So basically what we have here is two different answers for P squared, okay? And obviously they should be the same. So if I let P squared equal P squared, that means that minus C over A is equal to minus D over B. Signs cancel out, so I get C over A equals D over B, and then if I cross multiply, the B goes up above on the left, so BC multiply across by A equals to AD, and that's exactly what we were asked to find. Okay, so BC equals AD. Now this question here, I would have to say, is extremely tricky. Okay, we've been given that f of x equals 1 minus b to the power of 2x, and g of x equals b into the b to the power of 1 plus 2x. And we're told, find in terms of b the value of x for which f of x is equal to g of x. Now I'm actually going to write it the other way around. I'm going to let g of x equal to f of x. Now you're probably wondering, why did I bother doing that? And my reason is this. I noticed that the power of b in g of x is bigger than the power of b in f of x. So I thought, I think I'd like to have the one with the highest power of b on the left hand side of the equal sign. Now I know it's not any major importance, but it will help a little bit as time goes on. So if g of x is equal to f of x, we get b to the power of 1 plus 2x equals 1 minus b to the power of 2x. Now what I'm going to do next is, I've noticed that there's a 2x in the power of b on the left, and there's a 2x in the power of b on the right. So I'm going to try to isolate b to the power of 2x. Now 1 plus 2x, we know that addition means multiplication when we're talking about powers. So b to the power of 1 plus 2x is the same as b multiplied by b to the power of 2x, and that's equal to 1 minus b to the power of 2x. So now what I'm going to do is I'm going to bring my b to the power of 2x to the left hand side, so that they're all at least on the same side of the equal sign. So that will give me b multiplied by b to the 2x, which was already there on the left hand side, plus b to the 2x is equal to 1. But now I can clearly see that I have a b to the 2x in two different places. So what I'm going to do is I'm going to take that b to the power of 2x out of a set of brackets. So if I take b to the power of 2x out of the first part, I'm left with b. And if I take it here out of the second part, I'm just left with plus 1. And that's equal to 1. And again, just double check in your mind that what you've done is actually correct. So b to the 2x multiplied by b, well, that is b times b to the 2x, so that's right. And b to the 2x multiplied by 1 is b to the 2x. So yes, what we've done is definitely correct. Now that means, if we divide across by b plus 1, that b to the power of 2x is 1 over b plus 1. And now we come back to one of the most difficult parts of algebra, the connection between indices and logs. Now we know from class that indices and logs are the inverse of each other. So if we bring a log across an equal sign, it creates indices, and if we bring an index across an equal sign, it produces logs. Now we know that if b to the power of something goes across an equal sign, it becomes log to the base b. So that's exactly what I'm going to do here. I'm going to bring the b to the power of 2x across the equal sign, but we'll bring the b, and what I'll be left with is 2x equals log to the base b of 1 over b plus 1. Okay? So if b to the power of 2x crosses an equal sign, it becomes log to the base b, just like I've said. Now I've noticed something else here as well. that I have division on the right hand side, and I know that when we're talking about logs, division means subtraction. So that's log to the base b of 1 minus log to the base b of b plus 1. But we all should know that the log of 1 is 0 no matter what the base is. So that means that 2x is equal to minus log to the base b of b plus 1. And that means that x equals minus a half log to the base b of b plus 1. Obviously on the last line there, all that I've done is just divide across by 2. So really this question was a clever game of, we just started by letting g of x equal f of x in the top left corner. Then I focused on trying to get b to the power of 2x on its own. And then when I had isolated b to the 2x, the next thing on my mind was how do I get rid of indices. And I knew that if I brought b to the power of something across an equal sign, I get log to the base b. So that question is one of the shorter questions in the homework, but it's actually one of the trickier ones. So I would imagine that a lot of you had problems with that. Okay, now let's have a look at the next question, question 4. Let f of x equal x squared plus k squared over mx. Now part 1, show that f of km is equal to f of k over m. Okay, well, this shouldn't be too difficult. So first of all, I'm going to work out what f of km is. Now f of km just means put in km instead of x. So instead of x squared, it's going to be km squared plus k squared divided by mx, and we're putting in km for x, so m multiplied by k over m. So f of km equals, if I square km, I get k squared m plus k squared over, on the bottom line, km squared. So that's the first part done anyway. F of km is equal to that. Now secondly over here, I'm going to work out what f of k over m is. And because it's a fraction, this is probably going to be just a little bit trickier. Now first of all, again, f of x is x squared plus k squared over mx. So it's going to be k over m squared plus k squared divided by m multiplied by x, and remember we're putting in k over m instead of x. Now what that gives me is k squared over m squared. Remember, if you square a fraction, you square the top and you square the bottom, plus k squared divided by, on the bottom the two m's cancel and I'm just left with k. Now the next thing I need to do is I need to get rid of that m squared. Okay, and the handiest way of doing that is to multiply every part of the fraction by m squared. So that means that f of k over m is equal to, now if I multiply the first part here by m squared, the m squared on the bottom will cancel with the m squared on the top. So I'll be just left with k squared. If I multiply this part by m squared, I get k squared m squared. And then multiply this part by m squared, I get k m squared. Now I think clearly you can see that this and this are identical. Sorry, this should be k squared m squared over here actually, sorry, slight error. So you can see that f of km is equal to f of k over m. So obviously then we can say that f of km equals f of k over m. Now I have to say this part of the question, most people got it right. It was quite straightforward really, there wasn't much of a problem with it. The next part, part 2, is much harder. So what we're told in part 2 is that if a and b are real numbers such that a is not 0 and b is not 0, and that they're not equal to each other either, show that then if f of a is equal to f of b, we must have ab equals k squared. Now part 2 of the question, I have to say, is just clever factorizing. Okay, now first of all anyway, we'll just write down f of x again. F of x is equal to x squared plus k squared over mx. So here goes. If f of a is equal to f of b, show that AB is equal to k squared. Right. Well, if f of A is equal to f of B, this means that put in A instead of x on the left hand side, so A squared plus k squared over MA equals B squared plus k squared over MB. On the right hand side I just put in B instead of x. Now first of all, what I've noticed is that there's an m on the bottom left and an m on the bottom right, so we can cancel those two straight away. Then I'm also going to cross multiply by A, which is going to go up there, and B, which is going to go up here. So B multiplied by A squared plus B k squared equals A multiplied by B squared plus A multiplied by k squared. Now again, from here on it's just clever manipulation and messing around with factorization. So what I'm going to do to begin with is I'm going to bring anything that doesn't have a k in it to the left and anything that does have a k in it to the right. So that gives me ba squared minus ab squared equals a k squared minus b k squared. Now on the left hand side, I hope you notice that both parts have an a and a b. Now if I take an a and a b out of the first part, I'm left with just an a, and if I take an a and a b out of the second part, I'm left with a minus b. So the left hand side is ab multiplied by a minus b. Now on the right hand side it's very obvious. You just take out your common a squared and you're left with k squared multiplied by a minus b. Now because we're told that a and b are both real numbers, that neither of them are 0, and that a is not equal to b, that means that this cancels with this, and we're left with ab equals k squared, which was the required result. Okay, now that's the kind of question that I have to say some people really went into a lot of messy equations to try to get there, but as you can see, if you sit back and think carefully about it, it's not a very difficult question. Okay? Now, question 5, the last question in the homework. This is again from a Leave Insert paper, and we're told that if x is equal to root p plus 1 over root p plus 1, express x squared minus 2x in terms of p. Okay, now as you know from class, I have more than a little bit of an obsession with difference of two squares, and you're probably wondering why am I even thinking along those lines now. But let's just say I've noticed something. I looked at the minus 2 here, and I've noticed that 1 minus 2 is minus 1. So I'm going to try to create a pair of brackets where one of them has a plus 1 in it and the other one has a minus 1 in it. Okay, so watch this. X squared minus 2x is equal to x multiplied by x minus 2. And again, look at that minus 2 up there. Now what I'm told is that x is root p plus 1 over root p plus 1. And then the second bracket, now you could skip this line, but I'm going to put it in just for clarity's sake. X minus 2 is root p plus 1 over root p plus 1 minus 2. So that's root p plus 1 over root p plus 1 multiplied by root p plus 1 over root p, and like I said up here, 1 minus 2 is minus 1. Now you can clearly see that this part here is the same as this part here, so the two yellow bits are the same, and then the two blue bits are the same, but they only differ by a sign. So obviously, clearly then, this is actually the difference of two squares. So it's going to be root p plus 1 over root p squared minus 1 squared. Now when I square this out, I've got to square the first. Well, if I square the square root of p, I get p. Multiply the first by the last and double your answer. So 2 root p by 1 over root p. And then square the last, which is going to give me 1 over p. And then I just this minus 1 here tagging on at the end. Now root p and root p cancel out, which gives me a 2 here, and 2 minus 1 is 1. So the answer is p plus 1 over p plus 1. Again, the 1 came from the fact that 2 minus 1 is equal to 1. So that's x squared minus 2x written in its simplest form. Now, as I said, the cleverness here at the beginning was my factorization, where I said x squared minus 2x is the same as x by x minus 2. So I was actively seeking difference of squares. Now, I had put a little bit of thought into it before I did it, but I suppose I'm just trying to drive home here the importance of difference of squares. So anyway, hopefully you found this video helpful and that it's helped you to understand your homework. Okay, thank you.